into a quick walkthrough, relatively, on how to upload a data file to Google Gemini 2.5 and to get some preliminary analyses out of it. This is not at all meant to replace more in-depth analysis with a software tool like R and or Python, but this is just to essentially provide a demonstration of what Gemini is currently capable of, and I'm sure it'll get better over time as well. I'm sure you can do this as well with ChatGPT, but I'm just gonna, for the sake of this tutorial, do this in Gemini since I already know it works. So obviously you start with a CSV file, and if this is, if you're watching this from my class, this would be on Canvas, but you would just go to that CSV file and then upload it to Gemini. So as you can see, I already have Gemini pulled up here. I'm using 2.5 Pro. I'll go to upload files, and then I'm going to upload the class assignment file, not the final project file, but I will actually go through what I'm doing for the actual class project, which should translate to other uses as well. So I'm just going to upload that. And what I'm literally going to do is I'm just going to go through each of these deliverables and essentially think of how to word each of them as a prompt. So describe data cleaning process, initial number of responses, rationale for removing responses, and final number of responses used for analysis. So before I even do that, I'm just going to have Gemini examine this file and form a column or row goodness. So generally, I recommend if you're using Qualtrics or survey files, I think this probably applies to other surveys as well, you'll sometimes get what are known as double header rows, and so I'll show you what I mean by that just here in a moment. So as you can see, I have a couple extra header rows here, and yeah, basically a bunch of data columns. These are actually fortunately already named, but in certain other types of data files, they might not already be named. And so what I would do is I need to typically delete these. And so you could probably have Gemini do this. I'm actually going to modify my prompt here in a second, but just for the sake of time, since these are already named, yeah, I'm just going to go ahead and delete these two rows. Since I already kind of can see what everything else is, I'll also get rid of some of these redundant columns just to make it a little bit more simple as well. Hit save. Latitude and longitude probably aren't going to matter. This column's all the same, so this is redundant. User language is redundant. They're all going to show up as EN. And so all I'm doing right now is just making it a little more simple to use this in Gemini. So I'm going to save this, and I'm actually going to re-upload it and just get rid of that prompt. Okay, so now I'm going to go back to here, and I'm going to say this is a data file I'd like to work back and forth with you on. So this is probably common knowledge to most of you, but with most LLMs, you typically want to start prompts off with a almost set of like subsystem instructions. These are the actual ones that you see. So you essentially start the chat with a set of instructions like, here's the context of what we're doing today, here's what I'd like to accomplish, and here's going to be what essentially the context of this is. So I'm basically telling Gemini that this is a data file that I'm uploading. I've already cleaned up duplicate headers, and I'm not going to say a survey data file, Qualtrics survey. The more context, usually the better. So I've already cleaned up duplicate headers and named the columns appropriately. I'd like to get some preliminary insights on it. such as the number of observations. That's item 1. Rationale for removing any responses, we'll talk about that in a moment, and then final number of responses. So there's the number of observations and any potential responses that may have been curb-stoned, having all the response given across the interval scale questions. So if you show thinking, this actually gives you a pretty good insight into what the model is doing. You can see that it is loading the file, examining the data structure, looking at which items are interval scales and which are not. And again, in this particular file, it does look like my actual values are the explicitly stated survey response. And so one of the things we're going to have to do at some point is also recode these. Let's see where Gemini's at now. Okay. So I'll hide this little thinking process and see what the result was. So 374 responses. Let's see if that's right. Should be down to 375, I believe. 367. Oh, interesting. So, oh no, 375. Yep. So that's 374. And that means that's the number of responses. 41 columns in the data set. I'll just take the word for that. That doesn't matter. Curb-stoned responses. And so it looks at these interval scale items, organizational trust, advertisement attitude, behavioral intentions, and CSR, perceived CSR. And this claims that there are probably no curb-stoned responses. Now, there are more thorough ways to check this in the future, but for the sake of time, we're not going to actually do that. Like this one kind of looks like 4s across the board, so maybe we'll actually check that afterwards. So but assuming this was right, we would say that there are no curb-stoned responses. A better way to check, before we proceed, let's transform all of the values in the interval columns to numeric values, then, so I'm going a little bit above beyond here, but I'm basically going to have it examine the variance of the responses, because obviously most of these people probably passed attention checks, and therefore technically all the responses wouldn't be the same. But if all the responses are 4 other than the attention check questions, then it's probably worth still removing them. So let's transform all the values in the interval columns to examine numeric values, and then create a new column for variance. So let's see if Gemini can actually transform these columns. It should be able to. There we go. So this is a preview of those transformed columns. NaN just means that it's a blank, so that means that the person that left it blank, so that's fine. But as you can see, actually variance is pretty good overall across the board. Yeah, there are some variance in responses. So are any of the variances for these rows concerning the map could look like curb stoning? Assume we had 2 or 3 attention checks within the interval items. So someone could have passed the attention check and then continued curb stoning. So I'm obviously going way more into detail than most people probably would on this. And there are definitely faster ways actually to do this with just some Python script or R codes, R commands. But I figured I'd just do the demo for this in case you want to have authentic data. And I'm also kind of curious if Gemini can handle this. So of course Gemini is trying to now figure out what constitutes concerning variance. Yeah, I mean 0 variance would obviously be concerning, but close to 0 would be pretty close, would be in that ballpark as well. Okay, so here's actually a distribution of response variance. That's pretty nice that it actually did this. So there are several responses with concerningly low variance. This is the distribution that actually created a nice little graph for us. This is, yeah, fantastic. And as you can see, number of respondents that have below 0.5 variance, meaning that almost all their responses were the same, are 10, like maybe 10, 6, 16, 22, 27, give or take. So yeah, that's probably worth removing. So yeah, then it gives us U text. Looks like it's glitching a little bit. Okay, so let's remove any responses that have a variance of below 0.3. So I'm going to make the cutoff really small. You could use a different value if you wanted to, if you're doing this for the project, but this is worthwhile as well. So let's see if it does that. And it leaves 350 responses. So perfect, nice. So that would take care of the data cleaning process. Now, it already technically did list all the columns in the data set, but let's list all of the columns in this data set and identify whether they are categorical or continuous variables. So let's now see if it can correctly identify categorical versus continuous variables, which will then give us an opportunity to jump into data analysis since we technically already did the variable transformation. Well, actually not yet, so we'll do that too. So start date, categorical over time. I guess that's a liberal way of looking at it. Progress, continuous, duration, continuous, finished, yes or no, it's categorical, agreed. Recorded date, yeah, okay, I guess that's categorical too. Latitude, longitude, continuous, consent, categorical, instructions, categorical, not technically an actual column. Condition, definitely categorical. This is very important. Make sure you do something with condition if you have an experiment at least. Organizational trust are, so this doesn't actually follow it. They are technically ordinal variables, but it would have been, actually they're interval variables. Yeah, so we need to actually correct this because these are not ordinal. Demographics, all categorical. Age actually is continuous, so yep, that's good. And variance is continuous. The interval scale items are actually continuous. You can also give AI models feedback, but otherwise this is correct. Let's now create average columns for each of the continuous variables so we can then run analyses. So I'm going ahead and moving to the variable transformation step. So let's see. Interval scales are continuous, create new columns, organizational trust, advertisement attitude, behavioral intentions average, and CSR average. Perfect. Good. So, yeah. Okay, now Gemini is actually offering to run analysis for me, but I would like to do this manually. So what we're going to do is I would like to run each of these tests individually. And maybe we can actually knock it out with one prompt though. So let's actually try that. So I'm just going to paste this quick and then modify the actual wording. I'd like to run all of the following. Descriptive statistics. And instead of just saying one continuous demographic variable, I'm going to say for age, which I think is in this data set, right? So I could do age, that's the only continuous demographic variable, so yeah. So replace, and if you're doing this for a real data set too, you'd actually look at this carefully and identify variables that would be appropriate. So for this one, I'll do age, I'll do a cross tabulation, let's see, one nominal demographic and one dependent variable. So actually that probably wouldn't work for the dependent variable, so I'll actually do it for, let's say, a nominal variable, and we'll do a fun one. We'll do political. So let's do gender and political. It's always a fun one. Between gender and political. So chi-square test, two categorical variables. We'll also do that for on gender and generally it makes sense to follow up across tabs with a chi-square test to see if those observations are significant, because the chi-square test just tells you if there's a significant difference between two groups. The cross tabulation gives you the counts of each group in each category. So that might be interesting too. One-way ANOVA, that's obviously pretty obvious. And we'll say, we'll specify our independent and dependent variable. Try to put a one-way ANOVA and follow-up test on, let's see, condition I think was only two variables, so we actually need a t-test as well. I should probably add that, but yeah, we definitely need a t-test. So I'm actually going to paste this, add a t-test here. So t-test is going to be needed for our condition column because we only have two conditions instead of a one-way ANOVA. So we'll do t-test, put a t-test on condition, and I'll do this for one of these DVs that we just got. We'll do add attitude average. So whatever if you're looking at any of these continuous variables too, just as a rule of thumb for any kind of social science research, you typically want to look at the average scores of those without at least getting into more complex techniques like structural equation modeling and or machine learning. So you basically want to look at these averages because the individual items, since they're interval scales, are meant to be combined into one score. So do make sure to look at these and transform these into averages and not just satisfaction 1 or whatever else, or behavioral intentions 1. So let's see, got that. Oh yeah, and then regression. Multiple regression analysis. One-way ANOVA. So for our one-way ANOVA, we will do on political, which should have multiple categories, and perceived CSR, and then multiple regression analysis with actually let's do attitude average. Make sure to put these in quotes because tells it that's a column name. Average org trust average CSR average on behavioral intentions average. So just from a logical standpoint, behavioral intentions should probably be theoretically preceded behind like people's attitudes, which is trust, advertisement attitude, and perceived CSR. And so this just makes sense, but you can look at the data set, and if you come up with any other ideas, obviously go ham. So I'm going to run that and then see if it gives me any interesting insights. And this might be too much for the model as well, so if it doesn't address all of these, we'd have to run these individually. But I just want to get through this quick and see how it goes. Okay, descriptive stats, mean age, median, 21, standard deviation, 11.2. That's fine. It doesn't actually give me things like mode, and so descriptive stats I probably should specify further for the descriptive stats to give me all the measures of central tendency and dispersion, because this just gave me 3 out of 6 essentially, but it's fine for now. Cross tabulation, you have male and female, conservative, independent, liberal, none. And so that doesn't actually tell me anything yet though, because these are ultimately just people that completed the survey. So let's see. And chi-square test found no significant relationship between gender and political affiliation. So there you go, at least for the survey. T-test did find a significant relationship between the AI condition and non-AI condition on attitude. So that's actually interesting, because that tells us that there is a significant difference between the two groups. And Gemini actually did us the kind favor of actually looking at the means. And so the group exposed to the non-AI condition had a higher mean compared to the AI condition. So what that means is that people that see and know that an ad is from AI, that means that they actually have a lower attitude towards that ad. So that's actually pretty interesting. And let's see, this is also real research. One Way ANOVA did not find a significant value there, and this was on CSR across different political affiliations. So yep, that's fine. Multiple regression analysis between behavioral intentions, attitude, or trust, and CSR. We have an R-squared value of 0.69, which means that about 69.4% of the variation in behavioral intentions is explained by these 3 variables. So we're probably going to find significant value from that, and sure enough, our F statistic and p-value are significant. And so then it also gives you the coefficients, which is nice, and we see that the slopes of these are all pretty strong except for CSR, and that has a non-significant p-value as well. And so, just like that, you could now interpret the results. This does a preliminary interpretation for it, but I just kind of interpreted it out loud. You would have to look at this probably a little more carefully and think about what each of these things means, and that would be both a class project and actually pretty decent research too. So I will conclude there and hope this helps anyone looking to use large language models for some preliminary data analysis.